You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
All right, everybody. I get to start this week. Now, if any of you know me at all, I do play D&D. I play Dungeons and Dragons, and one of my characters is a half elf, and another one is an elf, and they have really, really long lives. If only humans could sometimes. Not all the time. It could be sad. But some real-life organisms can do this. Kirk, Victoria, can you name a few long-lived organisms?
Sharks come to mind.
Okay.
Trees.
Trees.
Oh, yeah. Very good.
Any other ones? Those are the big
Tortoises.
ones. Tortoises, yeah. All right. Well, this week, I'm going to be talking about an animal that is one of these long-lived species. I'm talking about the Greenland shark, also known as the Gurry shark or the gray shark.
I'm just going to speak for me and Victoria, if you don't mind, Victoria,
Go
that
ahead.
we are both shocked, completely shocked that you would go for an ocean creature in this podcast.
This has never happened before.
Right.
It's a first, truly. This is where I say that I'm staring at my ocean encyclopedia on my bookshelf. So, yay. So the Greenland shark is a large shark in the sleeper shark family. There is a Latin name. I wasn't going to even try. And it's found in the waters. No.
It's so entertaining when you do.
It is. I might try a little bit later. But
I'll tell you what, Rachel, I'll make a deal with you. If you try it, I will cut it out and people have to listen to the bloopers at the end.
Okay. I will look at that in a minute then. I have some Icelandic later, so we'll do that instead.
Oh, good.
Oh, Icelandic.
So it's found in the waters of the North Atlantic Ocean and the Arctic Ocean, so the northern hemisphere way up there. And it has one of the longest lifespan of all vertebrate species, like even more than tortoises and turtles.
Wow.
Nice.
Scientists think that their lifespan is somewhere between 300 and 500 years.
What now?
That is nuts.
Yeah. In 2016, scientists radiocarbon dated 28 sharks. They were able to use some crystals in the lenses of their eyes to determine what their age was. Because it's radiocarbon dating, they're using the carbon in their body to try to figure out, because it has a very specific half-life. But because of that, it has a very big variability. So
yeah, there's some wiggle room in there.
Yeah. So the largest ended up being the oldest, because they continually grow even slowly. And they estimated it was about 392 years old, plus or minus 120 years.
Right, as I say, that's going to be like your average and your value bars there. So,
Right.
So that shark could have been alive when Columbus was crossing the Atlantic.
A little bit after, because it was 15. When I was looking, it was around.
Can I
1500.
do math in my head? Yes. Yeah,
I can't.
Okay, so a little bit after.
I rely on a friend, so it's fine. A little bit after. Now, they also determined that, or estimated, that they reach sexual maturity at about 150 years of age. So it takes them
Hold on.
150
It's a really long
years
time to wait.
Oh,
before
man.
they could have any babies.
That does not seem like a successful evolutionary strategy there.
No, it
At
does
all.
not. It gets worse.
Oh my gosh.
So once they reach about 150 years of age, the females will use ovoviviparity, which means that they are developing the embryos inside of their bodies and
Correct.
give live birth. How long do you think their gestation period is?
No.
Given what you said, really long.
3 years.
5?
It's going to be long, right?
Oh yeah, those numbers were cute. It's anywhere from 8 to 18 years.
Shut up.
Shut the front door.
Uh-huh.
Wait, what?
I'm dead serious. They're pregnant from anywhere from 8 to 18 years with 10 pups.
Okay, hold on though. But do you know? I mean, I don't know if you looked into this. Like because if it's ovoviviparous, like they're in an egg, but the egg hatches inside. Like so, when you say 10 years, are they in the egg for like 10 years, and then they hatch out and are born, or is it like they hatch out and are like swimming around inside mom for 4 years? Like, do you know where that breaks down at all?
I don't, mainly because Greenland sharks are really, really hard to study. There's not a lot of them around. Generally, they have a uterus. So they actually, I'm pretty sure from what I've been able to tell, is that they emerge from the egg inside of the shark.
Correct.
Stay in there and are given birth 8 to 18 years later.
I'm just like, I want to know how someone like how do you find this out? You know what I'm saying? If they're this rare, do you like how do you even begin to know that? And that's one of the things I love about science is that people have figured this stuff out.
Yeah,
You know, it blows my mind.
This is I can post the paper that was on. That was a scientific study done in 2017. But yeah, it's
Bravo.
crazy. So beyond all of that, that's really what makes the Greenland shark absolutely bizarrely strange.
Correct.
It is also the largest living species of shark, at least in the sleeper shark family.
Okay.
Okay. Because I know the whale shark is much larger.
That's what I was thinking. I was like,
Right.
bigger than a whale shark? But okay.
Nope. It grows to be anywhere from 6.4 meters long, or 21 feet, to 24 feet long.
So that's no slouch.
Yeah.
No. And it will weigh anywhere from 1,000 kilograms, or 2,200 pounds, up to 3,100 pounds. Okay. And I'm going to describe the shark a little bit. So they have a rounded snout. They're decently long. They have a rounded snout, really small eyes, and they also have really small dorsal and pectoral fins. So their fin on their back, as well as their front, like, flipper fins. And their gills are actually relatively small, especially for the size of the shark that they are. Another
So
really interesting thing. Oh, go ahead, Victoria.
Are they pretty slow moving then?
Oh, we'll get into it.
Okay.
Generally speaking, too, their whole body is a pale, creamy gray or a blackish brown, and it's uniform over their entire body. There's no, like, variation anywhere, which allows it to be a generalist and be able to camouflage and sneak up on prey. Because, like you said, Victoria, doesn't have big gills, lives in the Arctic. It's an ectotherm. It's So because they're not fast, they hunt when their prey is asleep, hence sleeper shark.
Okay, all right.
And their swim speed, their max swim speed is 2.6 kilometers per hour or 1.6 miles per hour. That's their top speed.
Wow.
They're
I feel pretty safe about that.
yeah.
I think I could.
Yeah.
It's an endurance game, though, isn't it?
It's so much of it's very much endurance. They generally swim at about 0.76 miles per hour.
So what are they eating?
They're generalists, so they'll mostly eat fish. But they've been known to eat seals, and when they're younger, they'll eat squid. But they've also eaten smaller sharks.
So younger, like 120?
Right. They aren't found necessarily super deep in the ocean, but because they are a generalist in what they eat, they also scavenge, which means if there's a dead polar bear or a moose or a reindeer, they'll eat that.
Wow.
When they're actually eating live prey, what they'll do, they have a really large mouth, or oral cavity. So what they'll do is they'll open their mouth, they'll sneak up because of their coloration. They're not seen in the water. They'll sneak up, open their very large mouth, which creates a suction, and draw the entire animal into their body and into their mouth, and that's how they eat. So if generally speaking, scientists, if they've found a Greenland shark and are observing their guts, they'll find like whole fish or whole small sharks in their guts, in their stomach.
That's its
terrifying.
own kind of terrifying.
Right.
Yep.
Because you're like, oh, I'm swimming, I'm getting away, and all of a sudden, it's like, I'm in a shark.
Exactly.
Wow.
And it's even worse because they're not swimming away. Those animals are sleeping. So they don't even know. All of a sudden, you wake up and something is sucking you into its mouth. Terrifying. Now here is the time that I try the Icelandic. This shark, due to where it lives in the ocean, which is like the shallows or up to about 7,000 feet deep, and how its body works, its meat is actually toxic. It's really high in concentration of trimethylene N oxide.
That's not Icelandic.
No, it is not.
That's what I thought.
But once you ferment it and you treat it in Iceland, it lowers that concentration and it becomes a delicacy known as Castor Hakarl. I might have said that right. I probably didn't, but that was a try. And the shark actually uses that particular concentration for buoyancy in the water instead of like air balloon or whatever it is that water. I don't remember what the actual organ is that water bladder, air bladder. That's air bladder. That's the word that fish use.
I don't think they use the word. I think they use the organ.
Right. That's
Right.
the organ fish use.
Or also called a swim bladder, too.
That's it. That's all I have for you today. So after the break, we're going to come back and it will be Victoria's turn.
Me, I'm up next.
Yep. Sure to subscribe and leave a 5-star review. It helps other lovers of the strange find our show. You can also find and follow us on social media. Search for Strange by Nature Podcast on Facebook, Twitter, and Instagram, or come visit us at strangebynaturepodcast.com. We'll see.
All right, we are back, and inspired by Kirk's excursion the other week into the world of urine,
Oh, yeah.
I'm gonna go a little farther down that path. But first,
Great.
let's talk about fertilizer.
Oh, okay.
So
I want to say it's a 180, but it's not.
It's not. So you probably know that most modern agriculture is dependent on chemical fertilizers. It's one of the things that lets us feed 7.8 billion people,
Right.
and growing every day. And with fertilizer, there are three main nutrients, macronutrients that you need: nitrogen, phosphorus, and potassium. NPK are the chemical abbreviations. So if you ever buy fertilizer for your garden or your houseplants, you'll see on the label specific percentages of NP and K. We're not going to get into what those things do for the plant. It's not important to this discussion. But for the fertilizers that are used in the vast majority of agriculture these days, those things are made through chemical processes. Nitrogen is pulled out of the air in a very energy-intensive process called nitrogen fixation. Potassium is usually sourced from a potassium chloride, which is a common salt. And phosphorus is a little more tricky. So it's currently sourced from breaking down phosphate rock with acid, which is in a somewhat limited supply globally. Like, we're okay for now. Yeah, we're okay for now, but it will eventually run out.
Sounds like our original problems with oil. Yes.
Yes. So in the future of agriculture, sourcing phosphorus is going to be the most difficult aspect in terms of plant nutrition.
Okay.
Okay, so I want to step back and think a little bit about historical perspective here. What did people do before these modern chemical fertilizers? Animal manure.
Manure. Yeah.
Yeah.
There we go, manure.
Yeah. So there were some other things like crop rotation and wood ash and stuff, but a lot of it was animal manure. However, if you think about it, another major source of nutrients is out there, ready for the taking, and in fact was used in many societies.
You're not
human
going
waste.
There it is. Yep.
Yeah.
Or humanure.
Night soil is the usual
euphemism.
Soil, yeah.
Yep.
I love that.
Night soil is.
Be
that's
right
such a great
back.
term.
I need to have a night soil.
Well, wasn't that because people were like, they would chuck it out like the windows at night? Is that where that came from?
Something like that. Yeah, I didn't delve too deeply into the etymology, but sure.
You didn't delve too deeply into the night soil. That's probably for the best.
Yeah. So this was very commonly used in many cultures, usually untreated or only lightly treated, even into the 20th century in some countries. And in rural China, this is an extra special thing that you may not have heard of, although this is the kind of thing I wouldn't be surprised if you knew, Kirk. In rural China and on the Japanese island of Okinawa, there were also what are known as pig toilets. So this is literally an outhouse that was built over a pigsty, and you did your business, and it dropped down, and the pigs ate it.
I appreciate that you think I'd heard of that, but that's a new one to me.
I'm sorry. The pigs eat your poop.
Yeah, I mean, supplemented with other types of food.
Why not?
I suppose.
Yeah, that seems great for the pigs.
Pigs are notoriously not picky.
This pork shoulder tastes a little off to me.
Good way to keep the trichinosis in the family.
Right.
Yeah.
Obviously, there's going to be some public health issues, not only with pig toilets, but with spreading untreated feces on your farm fields.
Yeah, just a few.
Which is why this practice is diminished from what it used to be. However, in countries with modern sewage treatment systems, there is still a version of this. So the sewage sludge is often collected and treated, usually by composting and drying, and it is now called biosolids, and it is spread either on farm fields or used in landscaping, kind of depending on how much bad stuff shows up in it with testing. There are a lot
I've definitely seen it being done.
Yeah. There are a lot of concerns about heavy metals and pharmaceuticals. And if you think about our sewage treatment systems, it's not just toilet waste going in there. It's all the stuff from sinks and tubs and showers and washing machines and
People
Plus all
rinsing their paint brushes out, and
Yeah.
I'm thinking about all the things I put down my sink. Usually it's not anything bad. It's like paint and maybe bleach and things like that. Not great.
So there's some concerns with biosolids. But actually, if you get down to it, human urine is really where the bang for the buck is in terms of your macronutrients. It is.
Oh, God.
So the feces, I mean, just to get into the real nitty gritty here, the feces have a lot of carbon compounds and properly treated, they're good for the soil and soil health. But if you're talking about NP and K, the urine is where it's at. And human urine is even more valuable for this than cattle urine, for example. And so if you're thinking about the future of agriculture and where phosphorus is going to be coming from and trying to reduce the environmental impact of these other chemical fertilizers that we depend on, we may be looking at a future where urine is going to be playing a more important role. So people have been trying to work on waste management systems where you can separate out the urine and the feces. And actually urine, unless you're sick, is largely sterile, and it can be treated by simply storing it for a few weeks or months in a sealed container. And then...
Please don't try that at home.
Please don't do that.
Yeah. Well, it's good for your garden. I mean, some people do this.
I think what she's telling us is that she's got a big old jug of urine sitting around somewhere.
I do not. I think my husband would object. I am...
Oh, you think so, huh?
I mean, she has.
But honey, it's good for the garden.
I mean, are your, not to be that person, are your kids potty trained? Because like a potty training toilet, like that'd be like relatively easy to get a jug of that.
You make a good point, Rachel. My kids are potty trained.
That smells bad after like.
I said a sealed jar. Kirk.
Sealed container. Thank you.
If it's unsealed, the ammonia starts to evaporate, and then you lose a lot of the nitrogen.
That's true. Yeah.
Yeah.
That's fair.
Anyway, storing it that way, sealed for a few weeks, will kill all the pathogens because the ammonia levels increase, and that kills pretty much anything. And then, so if you're separating the urine, the feces are much less wet and they're easier to compost and dry. And if you're not adding water to it, if it's like a separating composting toilet, so that can be actually a very ecologically friendly way to provide all natural home source fertilizer for farm fields and gardens. So, the wave of the future, perhaps.
Maybe. I'm not doing it. Not right now.
I mean, we think of that as really, like, ew, gross and stuff. But historically, going back, urine was a very hot commodity. I mean, people did used to store urine, and there was like urine, brokers who would buy your urine from your house because it was used in even the washing of clothes. Urine was one of the ingredients, which seems so wrong to me. But literally, urine has been historically a commodity, and it's only now more recently that we're like, oh, just flush it down, put it in some clean water, and put it down the drain. It's which it's kind of crazy, but it maybe it's going to come full circle on that.
Yeah, and along those lines, when I was doing this research, there was a lot of information about Japan, which had a long history of using human waste. And if you think about it, think about Japanese cuisine being heavy on vegetables and fish and seaweed and stuff. They didn't have a ton of animal agriculture, so they were heavily dependent on human manure instead of livestock manure.
Interesting.
So it was very valuable.
That makes sense.
And so the cities were extremely clean, especially compared to European cities at the time, because all that human waste would just get carted away because it was so valuable.
Wow.
That is a really good point, especially since European cities at that point in time, especially, were just hot.
Rough.
There's a reason why there was so many diseases that went around so quickly.
Yeah. Well, that's about it on that topic. So next we'll be back with Kirk after the break.
All right. So remember last week when I talked about mitochondria?
Yes.
Yes.
The powerhouse of the cell.
Right.
The organelle that came to
Mitochondria
be.
are super fascinating, and the idea that we are chimera is mind blowing. But I need to confess something. The real reason I picked that topic wasn't just that I wanted to talk about mitochondria. It was actually preparation and background to get everybody ready to understand this week's topic.
Concerning.
So you're saying
okay.
if some of our listeners haven't heard that episode yet, they should probably stop, go back and listen to episode 14.
You might want to, yeah. You might
Okay.
want to, yeah.
That's fair.
You will recall that the original thing that eventually became mitochondria was what we call an aerobic prokaryote, right? Now,
Right.
I didn't touch on that first word too much, but aerobic basically means oxygen using, okay? These little ancient prokaryotes had the amazing ability to use oxygen as one of the key elements in this very complex chemical dance that creates ATP energy. As you can imagine, if photosynthesis had never evolved on Earth, that would not be a particularly useful skill, right?
Right.
Because if there's
Right.
not any oxygen out there, having the ability to use oxygen in the creation of ATP is not going to do you any good. In fact, before cyanobacteria gained the ability to photosynthesize and give off oxygen, there wasn't a whole lot of oxygen on Earth. And the very simple life forms that were here, they liked it that way. The event in our, history of our planet when photosynthesis evolved on Earth here is known as the Great Oxidation Event, or sometimes even the oxidation catastrophe. Now,
I like both of those names.
yeah.
Give a bonus to whoever came up with those.
Right. I don't know who came up with them. Interesting side note. The three of us, we all live in the state of Minnesota, and we have rich iron ore deposits here. That iron was originally dissolved in water in the oceans billions of years ago. And when this oxidation event happened, there was suddenly, for the first time, oxygen, free oxygen in this water, and it oxidized the iron, the dissolved iron in the water. And so it turned the dissolved oxygen into iron oxide, aka rust. So
Right.
sometimes it's called like the Great Rusting Event. Like all the iron in the water precipitated out and it sank to the bottom, where it got caught in sticky algal mats that eventually became rock that now make up the Iron Range of Minnesota. So if you look at the iron-rich rocks that are here in Minnesota, you're basically looking at ancient fossils. Like I said, the iron got trapped in algal mats and it formed layers as it was deposited. And there's a famous kind of rock here in our state called banded iron formation. And the layers of the banded layers are basically fossils of those gunked up algal mats that are full of all this iron that precipitated out of the water. So our iron industry is basically mining some of the oldest fossils on Earth, melting them down and turning them into cars.
I hate that now. I didn't
Why
like
do you
it
hate
before.
that? That's amazing.
I mean, it is amazing, but those were all fossils that we
You hate that they're being destroyed to do that.
Yeah, that's the part I hate.
I see. Okay.
I mean,
Well,
I didn't like it before, but now it's worse.
So it's thought that from the time cyanobacteria evolved, the ability to make oxygen, which is about 2.7 billion years ago, to the time it really started to show up in the atmosphere. I mean, it wasn't an overnight thing. It probably took about 400 million years for that level of oxygen to build up in the atmosphere to actually start having an effect. Now, remember, I said this was also called the oxidation catastrophe,
Yeah.
right? And you're like, well, wait, like why catastrophe? But just like oxygen oxidized the iron out of the water, it also oxidized methane out of our atmosphere. And methane is a potent greenhouse gas. So basically when this happened, it caused a huge global ice age because it cooled the earth down so much. On top of that, oxygen, we don't think about this because we breathe oxygen. Oxygen is pretty toxic. Oxygen causes oxidation of living tissue. So literally oxygen will damage DNA. And so this major change on Earth, which was the evolution of photosynthesis, also caused mass extinctions of many of these simple bacterial life forms that were not prepared for the presence of oxygen on Earth, which was basically toxic to them. This new selective pressure in the environment also drove evolution and likely led to the formation and proliferation of eukaryotic life that we talked about last week.
Okay.
We are eukaryotic life, as are most other living animal life you've ever heard of. So from our perspective, this was a very good thing. But to those life forms that could not tolerate this, it was obviously a very bad thing.
Very bad.
Right.
So here's the catch, though. Not everywhere on Earth is an aerobic environment. There isn't oxygen everywhere. We also have what's called an anaerobic environment, an environment where there is no oxygen. If you can imagine, if there's no oxygen, then mitochondria are not going to function. And mitochondria are basically at this point the basis of all eukaryotic life. It's how they function, right? So one of the cool things we now know is that there are bacteria that live in anaerobic or oxygen-free environments, and these are examples of extremophiles. So keep in mind that living things still need energy, and if you don't have oxygen in mitochondria to do this process of making, you still need energy
that gives you energy.
Yeah, and they found a couple unique ways that life has figured out how to make energy without oxygen. One of the really cool ways they found is that bacteria can create energy using nitrates instead of oxygen. They're basically doing the same process or a similar process to what we're familiar with, but using slightly different elements to make the chemistry work. So that is super cool, but it isn't what inspired me to talk about this whole thing this week. There was a story that came out recently this year that's a sort of bigger deal. Some scientists just this year revealed that for the first time, they have not just detected one of these nitrate-using bacterium, but they've discovered one living inside of a single-cell eukaryote.
Oh.
So, in other words...
Oh my...
You see where I'm going with this?
We're seeing it happen in real time.
Wow.
Oh, that's so cool.
So they've discovered a eukaryotic life form that is also symbiotic, like all other life. However, it uses a completely different bacterium to take the place of mitochondria. And this other bacterium uses nitrates instead of oxygen in the process of respiration.
That's crazy.
My mind is blown.
I love it. So, the symbiosis, probably, in all fairness, has not reached the level of this bacterium becoming an organelle like mitochondria. But like Rachel was saying there, we are basically watching an alternate evolutionary path for life in progress by discovering this.
So cool.
Yeah. So this symbiosis basically represents, a whole new branch of evolutionary life. It could have been the basis for all life on Earth had photosynthesis never developed, because this is an alternate way for species to get this energy they need. The symbiont organisms. Now here's a weird thing: when they were able to test it, they were to figure out they think that these two things, the bacterium and this eukaryotic single cell life, probably joined forces somewhere between 200 and 400 million years ago. Which, that's a long time ago, but in the history of the Earth, that's not that long ago, right? It's not a whole lot of time.
When you bring it onto the evolutionary scale, our human existence is just a blip. It's you mentioned this in a previous episode. It's minuscule.
Right. This is back in the time tiny. Of the dinosaur. We're firmly in the dinosaur time here, which is a lot of time to evolve, a lot more than we've had. But in the history of life in general, this is kind of a blip. It's not a whole lot of time. So one of the puzzles, though, that scientists are now trying to unravel has to do with the location of where they found these creatures.
I was going to ask.
Where they found deep in, I love this name, deep in Lake Zug. Or maybe it's pronounced Zug. This is in Switzerland. It's a stratified lake that has no oxygen in the deepest layers. So they were kind of looking for interesting things down there. But here's the problem. Like I said, this symbiont is thought to be 200 to 400 million years old. The lake only dates back to the last ice age. So like
What?
10,000 years ago.
Where did it come from?
Oh my.
Right. How did it get there? Now, it may turn out that these things are actually much more common than we think and are maybe in lots of, oxygen poor environments. It's very difficult to find and study these things. This is an amazing feat of research. So it could be that this just happened that came out this year. This was published. So there may be more of these elsewhere on Earth, and we're just kind of waiting to discover them. And so the idea that it ends up being in a lake is not that surprising, even though it's young, because maybe they're more common. But they're found in an oxygen poor an area that has no oxygen, and so it's like, well, why would this be hanging out in like a shallow lake? Like it wouldn't be, So there's lots of weird things to go with this. This is sort of like a whole new thing. I'm really excited to hear like, what do we know about this in a decade from now or 2 decades from now as we learn more about it. So there's likely like way more to be learned in the years to come. But this is a pretty new discovery I wanted to share because it totally shows how strange nature can be.
That's so cool.
I love science.
Thank you, Kirk. I hadn't heard of that at all.
I hadn't either. I love science.
It's so cool.
So cool.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange. Rachel, before we go on, we want to get the scientific name for those people who are listening all the way to the end of the podcast.
Right. So the Greenland shark is Somniusos microcephalus.
That was great.
That wasn't too
Pretty
bad.
good. No. I think I was thinking about the bobbit worm, which is way worse, so I'm not going to even try.
Oh, too bad.
That one was way worse.